Alright, so this time we're solving problem 46 from chapter 6. The question says, suppose you cut a massless ideal spring in half. If the full spring had a force constant K, what is the force constant of each half in terms of K? Hint, thinking of the original spring as two equal halves, each producing the same force as the entire spring, do you see why the force must be equal? If you cut this, and then part B, if you cut the spring into 3 equal segments instead, what is the force constant of each one in terms of K? So, to start off, we know that the force of spring is equal to the spring constant times the distance of the spring. So, we know that the constant is equal to the force divided by the distance. But for this instance, the force is going to remain the same, but we have and K, but it's going to be half of the original x. So when we solve for K, K is going to be equal to 2 times the force divided by x. And so if the force stays the same, the spring's going to have to be stretched, the half of the spring is going to be stretched further, so the spring constant is going to be equal to 2 times K in order to keep that constant, so it doubles the spring constant. Part B says, if you cut the spring into 3 equal segments instead, what is the force constant of each one in terms of K? So it's going to be the same thing, except for we're cutting the spring into thirds. So you're going to have the force is equal to the spring constant times the distance divided by 3. So K is going to be equal to 3 times F over X. And so to make it match this, we divide the 3 we take the 3 to the other side. So it's going to be 3 times the spring constant is going to be equal to the same force. It's going to produce the same force. This shouldn't be that. This should just be the force. So the force is going to be equal to double the spring constant for halves and 3 times the spring constant if you cut it into thirds.